Hi everyone, my name is Mona Attarpour. I'm currently in my neurology rotation, and given my interest in neuropsychiatry, I will be presenting about childhood abuse effects on the developing brain. What is childhood abuse? According to Centers for Disease Control and Prevention, CDC, childhood abuse refers to any form of mistreatment or harm directed at a child or adolescent, typically under 18, by a parent, caregiver, or another adult. What are the types of child abuse? There is physical abuse, like hitting, kicking, shaking violently, any traumatic brain injury, basically. Sexual abuse, forcing or coercing a child into sexual acts or exploitation. Emotional or psychological abuse, insulting, threatening, bullying, or withholding affection from a child. All these can diminish a child's sense of safety and self-worth. Then we have neglect, is failing to provide basic needs for like food, clothing, shelter, or medical care. Witnessing violence, it can be either domestic, where children can witness a parent being harmed or degraded. And then there is the non-domestic violence. That's when, for instance, witnessing a mass shooting at school or any other violence against another person. Then there is exploitation, forcing a child into labor, trafficking, or criminal activity. And institutional abuse is when children are harmed or neglected by the very system that are meant to care for them, like the orphanages, group homes, boarding schools, or detention centers. And the last one, which is a more severe one, is collective or mass trauma. This is seen in children of war, where the trauma may include violence, displacement, loss of their family members, and even starvation or denial of medical care. So what's the prevalence of child abuse in the United States? According to National Children Alliance, here in this graph, we can see the top three reported cases, which is sexual abuse, physical abuse, and neglect. On the right side, this is the age distribution among the children. And as we can see, the highest reported cases are between the age of 11 to 17. We will talk in detail about the following: the neurobiological effects of childhood abuse, especially structural and functional brain changes, as well as neuroendocrine dysfunctions. So what are the key brain regions affected? We have the hippocampus here in purple, which is our memory builder, helping us form and organize new experiences. Then the amygdala here in blue, which is a small almond-shaped structure, which is for emotional processing, especially the fear response. It basically warns us when there's danger. The next structure affected is the prefrontal cortex, which is the control center, guiding us with decision-making and focus and impulse control. And it's shown here in yellow. It's like an area of the brain. Then we have the corpus callosum, which acts as a bridge between our two hemispheres, the right and the left hemisphere. This is the area where both hemispheres communicate with each other. They keep thoughts and emotions in sync. Together, these regions shape how we learn, react, and connect with others. So what structural changes do we see? When they looked at the hippocampus, they often found a reduced volume, especially in girls exposed to abuse before the age of 12. Then looking at the amygdala, they saw something interesting because the amygdala can either grow in size or shrink, depending on the timing and the duration of trauma. The corpus callosum starts thinning, basically impairing coordination between thinking and emotions. And the prefrontal cortex often shows reduced gray matter, decreasing emotional regulation and decision-making. is more structural brain changes. When we talk about gray matter, what we mean with gray matter is the brain's control. These are basically brain's control rooms where information is processed, decisions are made, and thinking basically happens here. And when we talk about white matter, this is the brain's communication cables carrying messages between these control centers or control rooms. And so they work together so that the brain works together as one system. So trauma before the age of 5 has its greatest impact on the gray matter volume, which is the brain's intellectual center for learning, memory, and emotional processing. But chronic abuse has shown especially for many years, has shown that the white matter gets altered, basically the wiring that connects the brain regions. Here are diagrams comparing the average cortical white and gray matter in typically developing children compared to children with a history of abuse. So the right bars, as you can see here, up here and down here, are presenting the average cortical matter, whether it's white matter or gray matter. And on the left side, the left 2 bars here and here, they're representing the cortical matter in children with a history of abuse. As you can appreciate, children with history of abuse have a lower cortical matter compared to that of an average developing brain. Here we can see a comparison of brain activity, particularly in the prefrontal cortex, presented here in blue circles. So on the left side, we see a perfectly healthy brain with a lot of activity, colorful, bright colors like red and yellow. And then compare that to the right brain, which is a brain of an abused individual, which you see a lot less activity. There is less colorfulness, and even there is some atrophy going on. So the prefrontal cortex, which is the brain's control center for focus, decision-making, and emotional regulation. An example, in children exposed to trauma, this area often shows delayed, disrupted development, as well as reduced volume and activity, as you can appreciate in this picture. So this can lead to poor emotional regulations, impulsivity, and executive dysfunction, like planning, attention, and self-control. Next on this slide, we can observe hippocampal atrophy on the left and normal hippocampi on the right. This is normal. Research shows that childhood trauma can shrink the hippocampus and slow new brain cell growth, and therefore cognition, as well as making new brain, making the brain more vulnerable to stress and mental health problems later on in life. For example, an adult who endured chronic childhood abuse may struggle to recall specific events from the past, like their memories might be fragmented, times disjointed, or they may even be gaps and distortions when they're trying to remember traumatic periods. Let's look at changes to the amygdala, the small almond shape we talked about. This on the left side, you can observe the brain of a healthy individual, while on the right image, you can appreciate the difference with focal bilateral amygdala damage. In people who experience trauma, this region often shows hyperactivity. That means the amygdala reacts strongly to perceived threats or emotionally charged situations. For example, an individual may feel intense fear or even anger in response to what seems to be a minor conflict. But this is not just the change in activity. We also see a size change of the amygdala. which is not like the amygdala size, it's not uniform in everyone. So the size can either change based on timing and the duration of the trauma. For example, during early development, the deprivation of children is often linked to a larger amygdala, while chronic abuse is observed to have a smaller amygdala volume later in life. On this slide, you're looking at a mid-sagittal T1 weighted MRI image of the corpus callosum, which connects your two brain halves. The image on the left shows a normal corpus callosum of a 4-year-old child. And on the right, you can see the thinning of the corpus callosum of a 4-year-old child as well that has experienced maltreatment or early abuse. So the damage to the corpus callosum can make it harder for children to express themselves emotionally, leaving them seeming flat or disconnected. This can also affect their coordination, like handwriting or catching a ball. Okay, beyond the changes we can see in the brain structure and function, childhood abuse can also throw off the brain stress response system. What we can call a neuroendocrine dysregulation. Our bodies have a built-in alarm system called the hypothalamic pituitary adrenal axis, also called the HPA axis. It commands the center for how we react to a stress or a threat. So here's what happens. So the hippocampus releases a chemical CRH, or a corticotropin releasing hormone, which then reaches the pituitary gland here. The pituitary gland then releases adrenocorticotropin hormone, which gets into the bloodstream and then reaches the adrenal glands sitting on top of the kidneys, which then releases cortisol. Cortisol, also called our stress hormone. Cortisol gets your body basically ready to react to a situation like the fight or flight mode. So for instance, it tends to increase blood flow, and it increases blood flow to your muscles, especially increases your energy levels. And another thing would be to increase your blood pressure and so forth, basically to get you ready to fight or flight. Then there is also a feedback inhibition. So once you have enough cortisol in the system and the threat is gone, then you have a feedback inhibition that sends the signal to the hypothalamus and tells them, okay, we have enough, please don't send any more cortisol, or don't go through this pathway again. However, in people who are exposed to childhood trauma or chronic trauma, this system is basically off balance and results in more cortisol secretion. So this pathway is basically not working. So for instance, children exposed to trauma have, since they have high cortisol levels in their bodies, they're constantly under alert. Like they're very jumpy, they are easily startled, they're unable to sleep well. They're also quick to overact to even small stressors. The opposite could also be seen in children who have lived through long-term traumas. They may seem numb, slow to react to danger, or just get unusually tired after a stressful situation, because their bodies they just don't release enough cortisol to trigger a normal fight or flight response. Okay. So what are the neuropsychiatric consequences of early childhood trauma? These individuals are increasingly vulnerable to the following mood changes. And the mood changes, basically depression. Another one would be bipolar disorder, major depression. Anxiety disorders, they're prone to having generalized anxiety, panic attacks, PTSD, or post-traumatic stress disorders, and intense social fear or phobias. Some individuals are more prone to psychotic symptoms, including hallucinations or delusions, and there's a higher risk of schizophrenia spectrum disorders. Personality disorders, particularly borderline personality disorders, are seen. In some cases, antisocial traits can also develop. There is also a greater risk for substance abuse as people turn to alcohol and drugs to cope with their pain. And then functional disorders like chronic pain, fibromyalgia, or psychogenic seizures. This can emerge later on in life. Okay, what are the cognitive consequences? Childhood abuse doesn't just affect emotions or alter the brain structure. It can have lasting effects on thinking and learning. It impacts the brain regions tied to memory, attention, and executive function, leading to measurable cognitive deficits in these children. Let's start with memory. Children exposed to trauma often have working memory problems. Their autobiographical memory, like personal events, can be fragmented, vague, especially in post-traumatic disorders. In terms of attention and processing speed, many struggle with staying focused, and processing information is slow. Then there is executive dysfunction. That's when these individuals have trouble with planning, organizing, shifting between tasks, or controlling their impulses. Decision-making can be impaired in these individuals, leading to more risk-taking or impulsive behavior, such as gambling. Even language skills are affected. Some children have delays in verbal IQ and weaker reading comprehension. So overall, these individuals suffer from academic underachievement, unfortunately, compared to their peers who weren't abused. These outcomes remind us that early trauma doesn't just leave emotional scars. It can change the way children learn, think, and interact with the world for years to come. What are the long-term functional impacts? So unfortunately, there is a higher risk of suicide attempts and self-harming behaviors, often as a way to cope with the emotional pain that these individuals are going through. In terms of interpersonal difficulties, relationships can be difficult for these individuals. Many develop insecure attachment styles, finding it hard to trust and feel safe or maintain close connections with others. In terms of occupation, like work, school, and social interactions often suffer in these individuals as well. And as we mentioned before, chronic physical illness are also common due to stress and immune system dysregulation. For instance, cortisol, unregulated cortisol can actually decrease your immunity, and you're less likely to fight off diseases. All right. Well, let's say kids are basically gummy bears, right? So why don't they just bounce back and heal on their own? Well, children's brain are incredibly plastic. They form new neuronal connections rapidly, making it easy to learn, adapt, and even recover from adversity. However, plasticity is basically a double-edged sword. It can also wire in maladaptive patterns as well, like being more hypervigilant or having heightened stress response that may last into adulthood. So the idea that kids always heal on their own is unfortunately a dangerous misconception here. What are the neuroprotective or preventative measures that could reduce these effects? So when it comes to childhood trauma, early detection, and safety are everything. So remember that. Early detection and safety are everything. Removing a child immediately from an abusive environment is vital. And screening early for trauma symptoms can lessen prolonged stress hormone activation like cortisol and prevent long-term brain damage. So early detection again. Then once the child is safe, stable nurturing care is very crucial. A consistent attachment-focused relationship can strengthen brain circuits between the prefrontal cortex and the amygdala, the small almond-shaped piece in your brain. Their circuit, if they're strengthened, the emotional regulations are better supported. Then what about therapies? Well, therapies like trauma-focused cognitive behavioral therapy, play therapy, and eye movement, desensitization, and reprocessing can help rewire fear circuits, integrating trauma memories and support healthy coping mechanisms. And enriching education and positive social connections would build cognitive skills as well. As stress reduction techniques like meditation, mindfulness, yoga, and structural routines can also lower cortisol and improve resilience. So even nutritional support can help. Proper medications when needed is important for these individuals, and strong communication support can help heal the brain. Strong communication support with their community and having basic community support can help restore development. And basically, all these can give these children the chance to thrive again. Well, thank you so much for watching. I hope you enjoyed this presentation. Please like this video, and if you have any questions regarding this topic, please post your questions below. I am more than happy to answer your questions. Thank you again.